So hopefully you enjoyed that video and it reminded you what your laws of exponents were. I've also written them for you here in your note packet, so in case it went a little too fast for you, just a reminder that we're talking now about the laws of exponents, which means that these laws will apply when we have a common base. So the product law says that if the base is the same, we're going to add those exponents. That quotient law, if the base is the same, then the exponent subtracts. When we're dividing, the exponents will subtract. The power law, which is when we have a power raised to a power, so that's when you see those parentheses, says that those exponents will multiply. And we're never allowed to have negative exponents in our most simplified answer, so we use the inverse to make that positive exponent. And then the zero exponent, very simple, anything to the power of 0 is equal to 1. So to practice some of these, let's just take a look at a few examples. So in number 1, you see we have everything in parentheses, and that 6b is being raised to the power of 0. So remember that when we use parentheses, it says that everything inside of that is being raised to the power of 0, and therefore, since anything to the power of 0 is 1, that whole thing will equal 1. In number 2, we have a negative exponent. 3 raised to the power of negative 2 means we want to use that reciprocal. So instead of 3 over 1, we want to use the reciprocal and say that this is 1 over 3 squared. And then we can simplify that further to say that 3 squared is 9. When you're dealing with questions like this where there's no variable, you can actually plug that into your calculator to make sure that those values are equal to one another. Number 3, we have the same law, but looking a little bit differently, we have the negative exponent in the denominator. So when we use the reciprocal, instead of being 1 over x to the power of negative 2, we'll use the reciprocal and we'll have x squared over 1. And we don't need to put over 1. In number 4, we're multiplying x cubed times x to the 4th, so we have the common base of x, and when we multiply, our product law says that our exponents add, and 4 plus 3 is 7, so we have x to the power of 7. In number 5, we're going to take care of a couple of different exponent laws all at the same time. So when we take a look at our coefficients, we have 35 in front of x to the 5th y cubed and negative 7 in front of x to the 7th y. So your coefficients, those will follow the same rules as always. So 35 divided by negative 7 is a negative 5. We have the common bases of x, so x to the 5th divided by x to the 7th. We have our quotient law, which tells us that our exponents subtract, and 5 minus 7 is negative 2, so we have x to the power of negative 2. And when we don't see an exponent, remember that we have an exponent of 1. So here we have y to the power of 3 divided by y to the power of 1. And when we're dividing, that quotient law says that those exponents subtract, so we have y squared. Okay. So now this question is going to really take 2 steps because we have a negative exponent, and so we want to use the reciprocal. So remember, just like in numbers 2 and 3, we're going to, instead of have x raised to the power of negative 2 over 1, we're going to use the reciprocal or the inverse. So we're going to flip that. Negative 5y squared will all be over x to the power of 2. Okay, so when you have a negative exponent in the numerator, it's going to come down into the denominator and be positive, and vice versa. Just like in number 3, when you have a negative exponent in the denominator, it's going to come up to the numerator and be positive. Okay. And then lastly, we have number 6. Again, we have 2x squared all being raised to the power of 3. So 2 to the power of 3, those are our numbers, so we're not using exponent laws. 2 is a coefficient, not an exponent. So 2 to the power of 3 means 2 times 2 times 2, which is 8. And then x squared to the power of 3, we have a power being raised to a power, which means our exponents add. And so we have 8x to the 5th. Okay, so those are the reminder of our laws of exponents. We want to make sure that we practice those next class because we're going to be getting into multiplying monomials and polynomials, so you're going to really need to know all of those exponent laws.